Welcome back. This is an Aleks training video on predicting the acid-base properties of a binary oxide in water. This looks terrifying. You've got two hard questions. You have to find what is the possible or probable or whatever products to these reactants and whether it's acidic, basic, or neutral. It would make a lot of people scared. But I'm going to give you some tricks that will help you, and I think you may actually find this very simple. I want you to see, first of all, what these have in common. All three of these are oxides with one other element. So it's binary, which means two elements. That's what binary oxide means. It's an oxide that's two elements big. Okay. Sometimes they're ionic. Lithium hydroxide, this is a metal, this is a non-metal. So this is an ion or ionic bond. This is two nonmetals. So that's a covalent bond. This is two nonmetals. This is a covalent bond. So sometimes they're metals, sometimes they're nonmetals. But so the first thing they have in common is they're all oxides, binary oxides. Second thing is they're all reacting with water. So I'd like you to put something in the back of your mind so that a red flag would go off. If you have a binary oxide with water, often you should ask yourself, I wonder if this is an anhydride. Anhydride is just fancy Latin for without water. So it's just remove water. If you've ever heard just add water, this is just add water and you get something back. It used to be something, and then you took the water out, and then you put it back in. So it's like your orange juice that you add water to and make orange juice again. You took water away from an acid, and it became an acid anhydride. Okay, so you look at something and go, okay, if I add water back, I add H2O back, do I have something I recognize? Do I have an acid that I recognize? Do I have a strong acid that I memorize? Remember, there's only 7. Do I have something that has H's and something else that is reasonable to say, hey, that's an acid? Or do I have a hydroxide, which often is a base? So you can ask yourself, maybe it's an anhydride. So let me give you a couple clues first. Metals, normally, so metals like lithium, anything on the left of the periodic table, metals usually form base anhydrides. A base anhydride. So it used to be a base, water was removed, and now if you add water again, it becomes a base again. Once it's a base, it does what bases do in water, and that's break apart. Remember that strong bases will completely break apart, and weak bases will partially break apart. Strong acids will completely dissociate, break apart, and weak acids will somewhat break apart. Okay, so metals normally form base anhydrides, and nonmetals will often form acid anhydrides. Okay, so let's look at this first one. We have lithium and oxygen and water. So lithium is a metal, so it would always go first if you were going to make a compound. Well, what do I have? I've got 2 lithiums, I've got 2 oxygens, and 2 hydrogens. Oxygens and hydrogens. That's how you do it. Oxygens and hydrogens would form hydroxides. So LiOH, now how many do I have? I've got 2 Li's, 2 O's, 2 H's. So that's the same as having 2 lithium hydroxides. What if I were to ask you to give me the products of that? What would happen if you have this is a strong base, it's a hydroxide, strong base. How does it break apart? Well, if you have 2 of them, well, you'd end up with 2 lithiums, and you'd end up with, which is aqueous, and you'd end up with 2 hydroxides, which is also aqueous. And that's exactly what you have here. As soon as you put the water back, it becomes a base again. And then what would the base do? How does the base break down? Well, the 2 lithiums will stay as ions. So you have 2 lithiums, which will be aqueous. Anything in group 1 is soluble in water. And what about the rest? It's going to be 2 hydroxides, and it's also aqueous. Well, what is it? Is it acid, base, or neutral? Well, I have no HO3s or H3Os. I don't have any hydroniums, so that's acid. I have only hydroxides, which is a base, and that's what I've got. I've got bases. So this would be a base. Now, if metals form base anhydrides and nonmetals acid anhydrides, then I look down here and I see, okay, P, that's a nonmetal, oxygen's a nonmetal, so this is a nonmetal. SO3, that's a nonmetal. Both of these are nonmetals. It's probably going to form an acid. So this is where as you learn things, you build things, you start being able to think back and forth of the different things you've learned. You'll say, okay, what acid do I know that's got phosphorus, oxygen, and hydrogen? Phosphate. What's the acid from a phosphate? Phosphate's PO4, -3. So I'll need 3 hydrogens. So it's going to be H3PO4 phosphate. Now that is a weak acid, so it's not going to completely break apart. So if it's a weak acid and it doesn't completely break apart, you're just going to leave this as your product. So this would be H3PO4 aqueous. Now I have to balance it. Let's see. I've got 4 phosphorus, and 1 phosphorus here. So I bet you it's just quadrupled. Let's check with the oxygens. On the oxygen, I have 10 and 6, so I have 16 on the left. 4 times 4 is 16. Yes, that's what it is. So it would be P4O10 solid plus 6H2O liquid yields 4H3PO4 aqueous. And that's an acid. That's phosphoric acid. So this would be an acidic. So now, if you find an acid that's a strong acid, and there's 7 of them, and you need to memorize them. Remember, it's the 3 in group 7, Cl, Br, and I. So HCl, HBr, HI. Those are 3 of the 7. Then you have sulfuric, H2SO4, nitric, HNO3. And then you have the last 2 are chlorate and perchlorate. So ClO3 and ClO4. So those are your 7. Those are your 7 strong ones. So look at this guy. SO3, add H2O to it. So now it's SO4 with H2. So I have H2SO4. That's an acid. That's an acid I've seen over and over again. That's sulfuric acid. So do I write it the same way I wrote the weak acid above it, H3PO4 aqueous? No, I can't, because as a strong acid, it never stays together. It always breaks completely apart. So it's only going to break apart into ions. So I'm going to end up with, and just do it the first time. There's two H's to give, but just do it the first one. So I have an H. It joins with water, and I get the hydronium. So that's the first one. That would be aqueous. And then what's left over? Well, just take one H away, and everything else is your leftover. So I've got HSO4 negative, which is bisulfate or hydrogen sulfate, and this is also aqueous. So what is it? Well, it's obviously an acid. You've got hydronium here. That's acidic. So what you're seeing is what you're learning is tying together. The more you learn, the more you tie together with other things you learn, and you start learning faster. So as we do this in class, if you stuck or whatever, I'll help you, but this is how you would guess. You would say, okay, binary oxide, it's going to be an anhydride. It's either going to be an acid or a base, and then just go from there. Great.